Here's the product rule. Y equals u times v when u can be differentiated and v can be differentiated. This is the solution, it's bookwork. It's u dv dx plus v du dx. Sometimes we write y dashed is equal to u dv dx plus v du dx. uv dashed plus vu dashed. So they're the same thing, that's the formula. So here you just label this u and this v. These two constituent parts are a product, and each constituent can be differentiated. So we can write down the answer straight away. U dv dx, sine goes to cos, plus v sine times du dx, which is 2x. Then we can tidy it up. X squared cos x plus 2x sine x. Next one. This is u, this is v then. So dy dx, or y dashed if you want to write y dashed, u dv dx, e to the x differentiates to e to the x, plus v, e to the x, times du, 4 comes down, x to the 1 less. And we can tidy that up, can't we? X to the 4, e to the x, plus bring the 4 to the front, x cubed, e to the x. Slightly easier on the eye, isn't it? This one, u, v, so dy dx then is equal to u times dv dx, cos goes to minus sine, plus v, cos x, times du dx, which is 1 over x. So the best way to write this is write the second term first. 1 over x cos x, or cos x over x, minus ln x sine x, isn't it? That looks easier on the eye really. But you'll get marks for both, wouldn't you, of course. Now here there's 3, so we'll have to do it step by step. We can label this u and this part here as v, can't we? And then we can work out this, because it's a product, we'll have to do it again. So it's a 2-step solution here. So the first step is dy dx is equal to u times dv dx. So that's d by dx of this, e to the x sine x, plus v, e to the x sine x, times du, which is 2x. Okay, good. So let's give ourselves a bit more room, because there's a few steps here. Okay, so what does that equal then? Well, let's write this term first, shall we? And we'll put the 2x at the front. So it's 2x e to the x sine x. That's easy to do. Plus the x squared times this stuff here. And now we'll label this bit that we need to differentiate u times v as a product, isn't it, in its own right? So when we differentiate this, we get u dv dx cos x plus v sine x times du, which is e to the x. So we end up with then, I'm going to write this, because it's x squared, so I'm going to write this term first. So I'm going to write x squared sine x e to the x squared sine x e to the x. Then I'm going to write x squared cos x cosine x e to the x there, and then I'm going to write this term at the end now, 2x e to the x sine x. And you'll notice in all 3 terms there's an e to the x common. So what we could do, I'm not going to, because I'm running out of space, I'll just do it on the same line. That's equal to, I'm going to take the e to the x outside a bracket because it's in all 3 terms. And that way I can just get rid of the one there, that one there, and this one here. There we go. That's that. All times by e to the x. So I've taken it outside a bracket, and that looks better. Easier on the eye, but this in principle is correct anyways. And that's the answer. So this one showed that this satisfies this differential equation. Okay, let's just give ourselves a bit of room then. We'll bring it up the top. Just get rid of this. and then we'll have a look at the problem. Okay, good. Give ourselves a bit more room. That should be plenty, shouldn't it? Okay, good. So let's have a look at this example then. Show that this satisfies this equation. We got second, first, and normal things. So let's get this minus x e to the x. Let's get dy dx then. U and v. U, the v dx, plus v, times du dx, which is minus 1. Okay, so dy dx then, dy dx is equal to minus x e to the x minus e to the x. Next one, d2y by dx squared. Let's run along the row. This is a product, u times v, and we've just done that here. So this part will differentiate to what we just differentiated this to. So it's minus x e to the x minus e to the x, wasn't it? And then the second part here will differentiate to minus another e to the x. So what have we got then? Let's see what we get. So substitution then. We've got one of these. So minus x e to the x minus 2 lots of e to the x minus 3 lots of dy dx, which is minus x e to the x minus e to the x, plus 2y, 2 lots of minus this, so that's going to be minus 2, isn't it? Minus 2 lots of that then, x e to the x. What does it equal? Okay, well we got, oh, here we go. We got a minus x e to the x, a minus 2x e to the x, that's minus 3x e to the x, but this, when you expand it, will give plus 3x e to the x, so they'll all cancel. And then we'll have minus 2 e to the x plus 3 e to the x, won't we, which is equal to e to the x, which is what we wanted to show at the top. So that's fine. So the quotient rule then, here it is here, when it's one thing over another, like a fraction, we use this quotient rule, v du minus u dv over v squared. Shorthand, sometimes we see it as v du minus u dv all over v squared. The other way you can, yeah, that's right. And it does matter which way round, it's u over v, and you start with v du minus u dv. So this is the shorthand, y dashed is equal to. This is the long-winded formula that we use. So let's have a look at the first one then. So dy dx then, here. Label this as u, label this as v. So it's v times du, cos goes to minus sign, minus u, cos x, times dv, which is 4x cubed, over v squared. X to the 4, oops, squared. Sorry about the dogs. So what have we got here then? Dy dx is equal to minus x to the 4 sine x minus 4x cubed cos x over x to the 8, isn't it? Over x to the 8. And we could split that up. So it could be, we could just do x to the 8. Should we do that? Over x to the 8 here. And over x to the 8 there. Split the fraction up. So that's equal to then minus sine x over x to the 4 minus 4 cos x over x to the 5, isn't it? Divide you minus top take bottom. And we'll write it underneath. It's going to be a 5 and a 4. Okay, good. Well, we could tidy that up. I'm tempted to just write it on ground level, actually, using indices. So let's do that then. Top take bottom, 4 minus 8 is minus 4. So it's minus x to the minus 4, minus 4, and this is x to the minus 5, isn't it? There we go. There's that done. Next one. See what we get here. So we got u over v again. So dy dx. It's v du, v, more than one term, put a bracket, times du, which is 2x, minus u, more than one term, put a bracket, times dv, which is 2x, all over v squared. Squared. So dy dx equals then, we got 2x cubed plus 2x, isn't it, for this bracket expanded, minus 2x cubed, and then it's plus 2x over the x squared plus 1 squared. The minus 2x cubed and the 2x cubed cancel, we get 4x over x squared plus 1 squared. Okay, tan x we can write as sin x over cos x. It is a standard derivative, but we're going to prove it by using the quotient rule here. So dy dx is equal to v du dx, sine goes to cos, minus u, sin x, times dv dx, cos goes to minus sine, over v squared, which is cos squared. Should we write it like that? Cos squared plus sine squared, that's a trig identity, it's well-known trig identity, it's equal to 1. So that's given over cos squared, and that's equal to 1 over cos x. We can write that like that, can't we? And that will equal sec squared, which is what we have on our tables. 1 over cos is sec, and it's sec squared, which we write like this, don't we? So tan differentiates to sec squared, as we already knew. Last one. U over v, so dy dx then is equal to v times du. Now du is a product, x sine x, so I'm just going to write it in like so, minus u, x sine x, times dv, e to the x differentiates to e to the x all over v squared e to the x squared. Okay, what have we got here then? It's going to be a bit long-winded. So it's e to the x times. Now this in its own right, we left it because it's a product, isn't it? So when we differentiate this sub-problem, it's u dv dx plus, that's the formula for products, v times du is 1. So sin x times 1 is sin x, minus x sin x e to the x, which you could write differently actually, but it's easier on the eye if we write x e to the x sin x, and then underneath we can write power u times e to the 2x. So what have we got here? We've got an e to the x common on top, this is one there as well, so we've got an x cos x minus an x sin x, put that next, plus sin x over e to the 2x. One of the e to the x's now on the top will cancel, so it would just be 1 e to the x, and that will go on to x. One of them's cancelled, so I just got rid of it. And we could actually write that up the top. If I bring that up, I'll just do it in one fell swoop here because I'm using a digital pen and a rubber, so it makes it easy. E to the minus x can come up top then. And that's what we get.